This is Coach Neil from Roger Bacon High School. Today's lesson is on solving one-step equations. On the last video you watched with Mr. Nabi, one of the questions he posed is, in the US there are 87,000 flights each day. How many days will it take for 261,000 flights to have occurred? One of the methodologies he showed you for solving this was to create a table with the number of days and the number of flights. So in one day there would be 87,000 flights, 2 days 174,000, and in 3 days there would be 261,000 flights. So by using the table we could quickly see that it would take us 3 days for 261,000 flights to have occurred. Why do you think the table works for this scenario? Hopefully you recognize that because the number 87,000 is not too far removed from the number 261,000, that by adding 87,000 to itself, you would quickly get 261,000. Unfortunately, as Coach Nabi pointed out, this methodology will not work in all instances. For instance, what if we wanted to know how many days it will take for 3,915,000 flights to have occurred? In this scenario, we really don't want to use a table because it would just take way too long. So what do? Well, hopefully we learned to define a variable. In this instance, I'm going to use D for the number of days. And typically that's one of the strategies we use. When we name a variable, we typically name it using the first letter of what it represents. That way we automatically can remember, okay, well, D represents the number of days. Or we could say something like, how many minutes would it take? And we would use the letter M. Or if we were looking for an unknown number, we simply use the number N. Although we know from algebra that we can really use any variable we choose. But again, in this case, I'm going to define a variable, D, for the number of days. And then I'm going to try to write an equation based on the number of days, D, times 87,000, which is how many flights occur each day. And I set that equal to 3,915,000. This was all discussed on your last lecture. What we're going to discuss today, though, is how we can solve for D in a problem just like this. First of all, when we are solving one-step equations, one of the things that we need to remember is that we are dealing with a balanced scale. So as you see here, this is a scale, an old-fashioned scale with two sides. If I would put weight on this side would go down and this side would go up, and the scale would no longer be balanced. However, if I put weight on the other side, the opposite would occur. One side would go down, the other would go up because of the weight on that side. When we are dealing with solving equations, we have to remember to keep the scale balanced at all times. So what that means is if we add something to this side, we also have to add the exact same thing to the other side. We have to keep the scale balanced. Some other things we need to remember. First of all, our goal, the most important thing that we're trying to do, the thing we need to focus on most, is we're trying to get the variable to stand alone, or we're trying to get the variable by itself. And in order to do that, we want to move everything else to the other side of the equation. For example, if I have something like x minus 3 equals 10, we want to get the x to stand alone, which means we need to move anything else to the other side. Again, I just wanted to remind you of the balanced scales. When in any equation, the left side is equal to the right side. And in order for us to maintain that balance, whatever we do to one side, we must do to the other. And in order to move anything in an equation from one side of the equation to the other, we must always use the inverse operation. So, as a reminder, we want to say that addition and subtraction are inverse operations. We call those additive inverses. Multiplication and division are inverse operations of one another. We call those multiplicative inverses. So if we are given an addition problem, in order to move things from one side to the other, we are going to subtract. And in a subtraction problem, we are going to add. If we are dealing with a multiplication problem, that's going to require that we divide in order to get the variable by itself. And if it's a division problem, we should multiply. So first, let's talk about addition and subtraction. So in order to solve an addition and subtraction problem, we are going to use the addition property of equality. So let me give you an example. We'll use the same example I showed you on the previous slide. X minus 3 equals 10. Now, I'm guessing all of you can say, well, Coach Neal, that's easy. X equals 13. And you would be right. But we need to know how to get 13, because eventually the problems are going to be much, much harder, and we're not just going to be able to look at it and see what the answer is. So right now, we have a true statement. X minus 3 equals 10. Remember, we need to keep the scales balanced. Right now they are balanced. The left side is equal to the right side. So we're going to use this property in order to solve for x. And what this property tells us is that if we have two sides that are equal, which we do, we can add the same number to both sides and not change the equation. So look at what I do. I am going to add 3 to both sides. Did I change the equation? No, I didn't, because I added the same thing on both sides. Well, why, Coach Neal, did you add 3? Well, in order to get x by itself. Remember, that is our primary goal. So what does that mean? Well, negative 3 plus 3 is 0. Obviously, we don't even need to write that there. 10 plus 3 is 13. So I have solved in this scenario x equals 13. The same holds true if we're dealing with subtraction. Again, we have the subtraction property of equality that says if I have two sides of an equation that are equal, I can subtract the same number from both sides and it still is equal. For example, if I have y plus 8 equals negative 6, I can solve for y by subtracting 8. And remember, what I do on one side, I must do to the other. So this is y plus 8. I'm going to subtract 8 so that I get y by itself. Again, y plus 0 equals negative 14. One of the other things I would remind you and encourage you to do is check your work. If we know that y plus 8 equals negative 6, and we've said that y has a value of negative 14, does this check out to be true? And of course we know, yes, it does. So that's just a way for us to know whether or not we've done the problem correctly. As we said a few slides ago, addition and subtraction are inverse operations. So in our first example, we had a subtraction problem and we used the addition property of equality. In our second example, we had an addition problem and we used the subtraction property of equality. Well, now I'm going to show you how to use the multiplication property of equality. Let's say we have a problem like this. C divided by 4 equals 21. As you can see, this is a division problem. And what we've said in any division problem is we can multiply both sides of the equation by the same thing and the equation remains equal. In this case, we always want to identify the denominator of the fraction and multiply both sides by that number. hopefully we can see here that we would have 4c over 4, and the c's would cancel. This allows us to get c by itself. So c actually equals the product of 21 and 4, or 84. And again, I would encourage you to check your answer. If we look at the problem, c divided by 4 equals 21, and we said that c has a value of 84, we see that those things are in fact equal to one another. So we know we did the problem correctly. Finally, we can look at an instance of division. The division property of equality states that if two sides of the equation are equal, we can divide by the same non-zero number, and the resulting equation is still the same. So let's take an example like this. 5t equals negative 30. Now again, I know most of you are thinking, well, that's easy, Coach Neil. T equals negative 6. And again, you would be right. But it's the division property of equality that allows us to make that conclusion. In this case, 5 is the coefficient of t, and in order to get t by itself, again, that is our goal, we want to divide both sides by the same number, and then that, in this case, that number is the coefficient of the variable, which is 5. Again, you can see that 5 divided by 5 is 1t, which is exactly what we want to solve for, and negative 30 divided by 5 is negative 6. And I will leave the check up to you. Hopefully this made sense to you. If it did not, here's a few resources that will give you some additional help. Finally, as you look back through this exercise and look back through the video, I would like for you to try some in your book. So, if you would turn your book to page 86, I would ask you please to try the following. On page 86, try numbers 1 through 15.